Okay, so how a microphone works. So get your title down, and the first thing we start with, in a microphone there is a permanent magnet, and the permanent magnet takes like almost like the shape of an E, a bit like, or much like we had in a loudspeaker. So this is a permanent magnet. I'm not going to do a three-dimensional drawing, but if you imagine it's actually a circular magnet where this part and this part form the circle. If you imagine it came all the way around in a loop, and then this is like a central part that stands up from the centre of it. So almost if you were looking top down, it would look like this top down. So that would be like the outer part. It's almost like I took a section through there, and then inside there's another part of the magnet that stands up. So there's a permanent magnet, and as it's a permanent magnet, it's going to have some fixed poles. So that central part is north, say, and the outer parts would be south poles. Okay. And around that, we have it's a diaphragm fitted on the microphone. It's a very, very fine diaphragm, really fine. I mean, it's sort of thin like foil, really, on these microphones. In my previous job, we used to have to look at microphones. We used to have to calibrate them as part of our role, and you would see most microphones have like a protective cover over them, over this diaphragm, which is very, very thin, to stop them getting damaged. They're very easily pierced or scratched. And that diaphragm is attached to almost like a stem there that slides over the circular part of that magnet there. And then around there we have a coil of wire. So this coils around. Coil of wire there. And down it comes. Okay. So let's get this labelled. So we've got a permanent magnet, we've got a diaphragm, and we've got a coil. Oops. And this is our wire. And again, this wire is insulated, so there's no electrical connection between the coil, between the part of the diaphragm there. You've just got that wire wrapped around it, insulated wire, sort of plastic wrapped around it. Okay. Right, so this is what happens. So when sound waves, I'm going to make a little bit of space over here. When sound waves, these are our notes to go here. When sound waves hit the diaphragm, they cause it to vibrate. So, key words there. This idea that sound waves hit diaphragm and it starts to vibrate. Okay, sound waves, remember, are these waves of pressure that forwards, backwards in the air. High pressure, low pressure areas. Okay, so all those particles bashing into each other in the air. Okay, and then those bash onto the diaphragm and cause it to vibrate. Okay, so if that diaphragm's vibrating, then that coil will start to move in and out of that magnetic field. Okay. So this causes the coil of wire to move in and out through this magnetic field. And from here, as soon as we start to see this idea of something moving, or a coil of wire moving in a magnetic field, we should be quite understanding of this idea that you get this current induced. It's a bit like using the generator effect, okay? So this movement, this coil, so that's going to be moving back and forth into there, okay? Through this magnetic field, it's going to induce a potential difference across the ends of the wire. This induces a potential difference across the ends of the wire. So you're going to have a potential difference across the ends of the wire here now. Okay, it's just this generator effect. Okay, like the reverse of the motor effect. So let's underline a few more keywords there. So what we've got this idea: sound waves hit the diaphragm vibrates, the coil moves in and out of magnetic field, and this induces a potential difference. Okay, right. This potential difference is going to keep switching directions because it's going forwards, backwards, forwards, backwards, forwards, backwards. Okay, it's going to keep switching directions, and it causes like an alternating current, basically. So let's write this over here. This potential difference alternates. Remember, alternates just means something switches direction. Alternates, that's mine, we call it alternates direction as the coil moves backwards and forwards. Okay. So it just means if that end started positive and that was negative, alternates, that would be positive, that would be negative. Then it will alternate again, that would be positive, that would be negative, and so on. And this is basically because the coil is moving in, so it will be one way, then as it moves out, it will be the other way. Okay? So, potential difference alternates because the coil is going backwards and forwards. Okay? And what we can say then, so let's roll this up a little bit. What we can say is the frequency of this alternating, the frequency of the alternating potential difference is the same as the frequency of the sound waves. So, keywords there, the frequency of that alternating potential difference, same as frequency of the sound waves. So it now means we've got an electrical current within our system, whatever it might be, okay, produced or matching the frequency of the sound waves that hits it. So we can now use this signal, maybe put it straight back to a headphone or a loudspeaker, okay? But it's a recorded electrical signal of that sound wave. And actually, if we could sketch it, you can imagine a sketch of this would look like this on a, if you were to trace it on an oscilloscope or to put it onto a graph, okay? Where we might have positive and negative potential difference up the side. So there's our graph there. So this will be potential difference. And as the sound waves moving back and forwards, as that sound wave moves back and forwards, the potential difference will alternate and you'll get this alternating potential difference, producing a wave there. Now, in fact, sound waves, a nice simple sound wave will produce a shape like this, but sound waves, even speech, is much more complicated, and it won't look exactly like that. The signal will look very quite convoluted, quite complicated, but you've got this idea of, because it's moving backwards and forwards, you'll have this general pattern of it moving upwards, downwards, positive, negative, positive, negative. And that there is your microphone, okay? Make sure you've got these notes in your book. Again, as we've gone through some other of our devices, I say that the key thing is you don't have to remember that word for word, but if in an exam you've got something down along the lines of, well, sound waves hit diaphragm, diaphragm vibrates, coil moves in and out of magnetic field, induces potential difference, this alternates backwards and forwards because a coil moves backwards and forwards, and jot down the idea that the frequency is the same as the frequency of the sound waves, you'd probably be on for most of the marks, if not all of the marks on that kind of a question.